You know what my favorite flammable food is? And it says something about me being a chemistry nerd, but I have a favorite flammable food. It's Cheetos. Now, let's see what goes on here. Take a Cheeto. Everybody having fun here at the Olympic machine? People running around and stuff? Yeah. Okay, so what do you think's in the balloon? Helium. That's a good guess. Sure, why not? Lighter than air.
Toasted Cheeto.
Flaming hot. It's a flaming hot Cheeto. Oh, kids, put your fingers in your ears. It's gonna be loud. Be loud. So, do we want to revise our estimate of whether that was helium or not? Would you let your granddaughter have those balloons by her birthday cake candles? No, I don't think that was helium. What was it, do you think? Air? Do you think air blows up like that? Well, actually, in a way, you're right. No, it was hydrogen, but it was also air. Because hydrogen went boom. But actually, hydrogen, in the scale of things, is not that reactive. What makes it that reactive? The fact that in air is 20% oxygen. The element oxygen. O2. Oxygen by itself. Now, oxygen by itself is very hungry for electrons. We have an atmosphere here on Earth that is tremendously reactive. It breaks down things all the time. It burns trees and forest fires. It rusts iron. It's an extremely oxidizing atmosphere because of all that oxygen in there. Now, oxygen is very hungry for electrons. And where did all this built-up oxygen come from? Well, this picture gives us a clue here. Where did all that oxygen come from? Well, it's in the sky, but trees, plants, for millions of years, plants have been ripping oxygen off of whatever it's already stolen electrons from and making those electrons back and spitting it back out in the air. So we've built up a lot of oxygen, 20% oxygen in the atmosphere. 18, close enough. That makes for, as a chemist, it makes for a lot of fun. Because it means I can do a lot of reactions with oxygen. Okay, let's take a real quick look at why oxygen is so reactive. If you look at the periodic table, have you ever seen the periodic table before? You know, it hasn't always been the same, you know. It changes sometimes. You know how often they change? Periodic. But if you look at oxygen here, right there, there's two types of elements. Remember, an element's just something that has only the atom itself in it. There's also the atom. Oxygen is over here in the non-metals. Now, ignore those right there. Those are the noble gases. They've already got all the electrons they want. They're out of date. But other than them, it's the strongest non-metals, the ones that are hungriest for electrons, are in the upper right corner. Okay, so here we got fluorine is the only one that's hungry, and it's poisonous for air. So, other than that, oxygen can take electrons away from any other element. Now, metals will sometimes take them completely away. Other non-metals will just kind of share the electrons with them, but it'll keep most of them. If they ever shared an ice cream cone with your big brother, you know what I'm talking about. Oxygen gets most of it. Okay, so we're going to take a look at oxygen reacting with some metals, taking the electrons away from metals. We're going to look at potassium, magnesium, iron, aluminum, and also we just saw it take away some electrons from a non-metal, hydrogen. That was oxygen taking the electrons away from hydrogen over here. And also, we're going to look at an oxide of carbon. Anybody think what an oxide of carbon? Like a dioxide of carbon? Carbon dioxide, right? So we'll be taking a look at that. Okay, first of all, let's take a look at the reaction with magnesium and oxygen. Okay. I've got some magnesium here. Magnesium is a metal. You can switch around my eye protection for this. Like a metal, you see, it's kind of, you know, flexible, shiny. That's what metals do. And we're going to get it to react with the oxygen in the atmosphere. You see, it combines to make it really bright. It gives off a lot of energy in the form of light. The magnesium is combining with the oxygen to make magnesium oxide. You can tell reactions happen because, first of all, the one hand has a lot of energy change, and also we got that stuff, which is not at all like the metal. It's a white powder, white crumbly substance. That's magnesium oxide.